Alrighty, so what is ECG? Well, ECG is electrocardiograph. What is it? It is basically a way of measuring the electric activity of the heart. Okay, so basically, you've got the heart in your body, it's in your chest, and it's beating. Okay, and when the heart beats, how does it beat? Well, actually, there are cells within the heart, and so basically there are cells within the heart that send out electrical signals. Okay, these are pacemaker cells. These cells, when they send out an electrical signal, it goes throughout the muscle of the heart and it continues through its pathway, and it goes throughout the muscles of the heart and causes the heart to contract. It causes the muscle of the heart to contract, and thus you have your heartbeat. That's an oversimplified version, but that's pretty much all we need for the time being. So because of the fact that the heart is producing electrical signals to make it beat, therefore if we have some sort of method to sort of like detect the electrical signals of the heart, it'll give us an idea of how the heart is functioning, or if there are any problems with the way that the heart is functioning, you know. So heart works by electrical conduction through the heart and causes contraction of the muscle of the heart, and so if we can see this electrical if we can detect these electrical signals, it'll give us an idea of about how the heart is functioning. And so we use the ECG. The ECG is called the electrocardiograph, and there's a picture of it right here. Okay, and basically how is the ECG recorded? It's basically a bunch of electrodes. Electrodes are basically electric signal sensors. Okay, they are placed on the surface of the body. Okay, because basically when the heart is doing that electrical activity, the electrical signals don't only go to the muscles of the heart. A bit of that electrical signals goes through the like those electrical signals. They can be detected on the surface of the body. They can be detected on the skin. So basically, if we put electrodes on the skin near the area of the heart, it'll help us. We will be able to detect these electrical signals. Okay, and thus give us an idea about the how the heart is working. So basically, we would put, for example, an electrode on the right arm. This is the typical way. We put an electrode on the right arm, the left arm, and the left leg, and it gives us an idea about how the heart is functioning. More details on this soon. So this is an ECG recording. Okay, you've probably seen it in some shows or something like that, and this is what comes out of the ECG machine. This is the electrocardiograph. Okay, and basically what the only thing that you need to know for biophysics is just some simple thing. You need to know the names of the waves and what they correspond to, but you need that later on. For the time being, all you really need is just these three beats. This is what we'll be focusing on. Just a quick summary is like P, Q, R, S, T. Okay, it's like P, Q, R, S, T. But you don't need that. You just need Q, R, S for the time being. Okay, this is the part where the ventricles of the heart are contracting, and this is the main thing you need for biophysics for the time being. Okay, or at least for the biophysics credit. Okay, so Q, R, S. What is this? Basically, Q is the first negative signal. So basically, the first signal is going downwards is called Q. Then the first signal is going upwards is called R. Then the second signal that's going down is called S. So basically, just know that Q, R, S. This is called the QRS complex. The main thing that you need to know is that R is always positive. R wave is always positive. These are all R waves. These are all R waves. Okay. The Q, S are always negative. They're always the opposite sign of the R wave. Okay, that's all you need to know for the time being. Only for the credit, only like superficial theoretical knowledge is needed, just that much, which helps you understand what is going on in the question. So onwards, this is the main thing that you will be using ECG for in the credit test. It's called Einthoven's triangle. Okay, this is basically a triangle, like an imaginary triangle. Basically, when we want to detect the electric activity of the heart, like we said, we put electrodes on the body. Okay, where do we put these electrodes? We actually put one on the right arm, left arm, left leg. Okay, know this very well. Right arm, R, left arm, L, and left leg, we called F, like for foot. Okay, we'll get to this in a second. And basically, the connection between right arm and left arm is called lead 1. The connection between right arm and left leg is called lead 2. And connection between left leg and left arm is called lead 3. Okay, so we'll get to more details for that. But in all cases, Einthoven's triangle is the main thing that you'll be using, and it tells us about the electric activity of the heart. It is very important. How so? Well, what happens is that basically in every heartbeat, the electric signals, like in any given point in time, the electric signals are going in many directions, okay? And then they recollect, and then they go in many directions, and they spread around, all this. What we want, it's important for us to know that at any given moment, we want to know what is the average direction, what is the mean direction, i.e. mean axis of the electrical activity. What is the mean axis, i.e. the average direction of the electric activity of the heart? This is very helpful because, for example, if the patient has hypertension or some sort of heart attack or something like that, it can cause changes in the electric conduction of the heart, and it can cause changes of this average direction of the electrical activity, i.e. the mean electrical axis. Okay, so this is very important for us to know in medicine. Okay, so that is the use of it. So what is it? How do we use it? Also, how do we use it in the credit test? This is how it goes. Okay, you need to learn how to draw one. So first off, before going into the details of how do you draw the Einthoven's triangle, we'll first speak a bit about just something about the angle. Okay, the angle. So basically, the summary right now, what you should expect to happen is that you're gonna end up drawing this triangle. Okay, you're gonna end up drawing a triangle, and you're gonna end up with some sort of big arrow. This arrow is something that represents the mean electrical axis. What is the mean electrical axis again? Know the definition well. It is the average direction of electric activity of the heart. So mean is average, axis is direction, electrical is electric activity of the heart. Yeah, so mean electrical axis is the average direction of the electric activity of the heart, and this is what you're going to get from the question, or you're going to use in the question to get something else. Okay, and basically what's important for you is and the other thing you need to know is that this is called the isoelectric line. Okay, so after you've drawn the Einthoven's triangle, there's a line running through through the center, slicing the triangle in half, and it's parallel to this line. Okay, it's parallel to this line, and it helps us to designate what is the angle of the mean electrical axis. And there's going to be another line, let's just call it midline. Okay, and basically these two lines, what do they help us do? Well, they help us to designate what is the angle of this final it helps us to designate the final angle of the mean electrical axis that we find out. So for example, just first off, let me show you how it's done. So basically this is angle 0, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 130, 140, 150, 180, 190, 120, 120, 270. Okay, from this direction till here, it is from 0 to 90 to 180 to 270. Okay, it doesn't go beyond this. Okay, if you want to reach this area, you go the opposite direction. You start from 0 till minus is 0, minus 10, minus 20, minus 30, minus 40, minus 50, minus 60, minus 70, minus 80, minus 90. Okay, so basically this line right here is 270 and minus 90, depending on where you reach it from, depending on do you go like this, or depending on if you go like this direction. Okay, that's just some baseline, some basis to work on. Some stuff that you'll be using soon. So I'm just going to give you an example. So for example, you get that the mean electrical axis is like this. Okay, you do your drawing shebang, and you get this big arrow. Okay, and this arrow is your mean electrical axis. This is the average direction of the electrical activity of the heart. Okay, that you have found by doing your stuff. So what is the angle? Like, how much is this angle? Okay, we can roughly say that, well, it's between It's between 90 and 180. It's between 90 degrees and 180 degrees. So that tells us it's somewhere between 90 and 180. Okay, so let's just roughly say it's like 120 or something like that. All right. Of course, there's an easy way about how to find exactly what the angle is. We'll get to that in a second. But now I just want you to visualize the areas of the angle. So this is 0, 90, 180, 270. So this is if you go in this direction, in the clockwise direction. From 0 to 270, it's clockwise direction from 0 to 270. If you go counterclockwise, so if this arrow was pointing here instead, you would go counterclockwise. You go 0 to minus 90, okay? So if the arrow is here, it would be somewhere between 0 and minus 90. It could be minus 20, minus 30, minus 40, minus 50, minus 70, etc. You got the idea, right? So that is the idea of the angles and some background of what is mean electrical axis. Now we are going to get to the most important point. All right, we are going to draw the Einthoven's triangle, and it is very important. It is basically how this goes, is that in the credit test you are going to get quite a few ECG questions, like a minimum about 5 questions, okay, typically, and basically for every question, like if you master this, ECG is going to be your easiest question ever, okay? All of your ECG will be your easiest question, okay? And also this knowledge, it's not going to be limited to biophysics as well. Whatever knowledge you gain about ECG is going to carry with you throughout the years, up until literally up until 6th year. I do not exaggerate. Like every year they remind us about ECG. So basically, you got biophysics now, then next year you've got physiology, you got ECG, then the year after pathophysiology, ECG, then in 3rd year, then 4th, 5th, and 6th year you need ECG for internal medicine. So it's a very, very key skill. And this right now, you are still young, so let us just start with the most basic thing, which is getting Einthoven's triangle. And just the main point here is that right now, go fetch a piece of paper, pause the video, fetch a piece of paper, fetch a pen, and draw step by step with me, please, okay? Because every question of ECG you get, you are going to draw this triangle, okay? You're going to draw this triangle, and based on your drawing, you conclude what is the answer, okay? And if you master this, easy peasy. It's gonna be your easiest question, all right? So I'm not gonna give you a while to go fetch a paper and pen, because you can just pause the video. But yeah, so starting off, we draw a triangle. Dun dun. Okay, so we draw an equilateral triangle. So you're gonna have this presentation, by the way, but okay, by the time you probably already have it. But basically, by the time I'm recording this, but basically, I've animated it, but just keep in mind that these animations don't work for Apple, okay? They don't work for the Mac operating system, so sorry, Apple people. It only works on Windows. This is just how Microsoft Office works, sadly. So basically, if you need any animations, you're just gonna need to go back to this video for the rest of the topics. Anyways, so first things first, you draw an equilateral triangle. Okay, draw. Bum, bum, bum. You drew the triangle. Next step, you number the leads. Okay, if you remember, we said, and you write down RLF, right arm, left arm, foot. Okay, so if you remember from the drawing, from the person drawing that we had before, it was like over here. This is what it's supposed to look like at the end. All right, right arm, left leg, right? And what connects here is this is lead 1, this is lead 2, this is lead 3, okay? And these are the signs, okay? Here, plus, plus, minus, minus, plus, minus, okay? We'll get to the details of that in a bit. But in all cases, first things first, you draw yourself an equilateral triangle, all right? So, you draw an equilateral triangle. You number the leads, so lead 1, lead 2, lead 3, and you write down RLF, so right arm, left arm, foot, okay? I don't know if this bottom part is being recorded, I sure hope it is. Anyways, you mark the centers of the leads and the center of the triangle. So we mark the center of the lead. We just roughly, like, this is all rough. Basically, no one's going to check your work. But if you want a correct answer, you need to try and be as accurate as you can. Not exaggeratedly, extremely accurate, but just as accurate as you can be. Okay, just roughly draw the centers of the centers of the leads and the center of the triangle. Okay, then mark the signs of the leads. Okay, what I like to do is I go plus plus, minus minus, plus minus. Okay, that's the easiest way for me to remember it. So next step, again, just to remind you, you have this presentation, and also you can go as slow as you want. If I'm going too fast for you, just decrease the speed of the video or something. In all cases, the next thing is that you roughly draw the vectors. Okay, what does this mean? So basically, in a question, you will typically get the following phrase. For example, it will give you, in this, whatever, in the electrocardiogram of some given patient, the amplitude of QRS of lead 2 is 2 millivolts, or something like that. And the lead 1 is 1 millivolt. The lead 3 is 1 millivolt, okay? Or he'll say something like, the voltage of lead 2 is kada, lead 2 is that, lead 1 is this, lead 3 is that. So basically he'll give you a bunch of voltages, okay, for this is also known as amplitudes for each of the leads. Okay, so in this example we'll just say that lead 2 is 2 millivolts, lead 1 is 1 millivolt, lead 3 is 1 millivolt. Okay, and so when you want to draw this, so it's based on, you get these values based on what is given to you in the question. So what we want to do is we want to roughly draw the vectors. Okay, just roughly draw the vectors on the triangles. Okay, how do you draw the vectors? Is that basically, if it's positive, you start from the center of the lead and you go towards the positive. Okay, and another thing is just like you can roughly say is that each millivolt is a centimeter or something like that, or whatever. Like, you know, just you balance it yourself, but just make sure that it's roughly proportionally correct. So basically, lead 2 needs to be double when you draw it. Lead 2 should be double the length of lead 1 and lead 3, because lead 2 is 2 millivolts, lead 1 is 1, lead 3 is 1. So lead 2 should be double the length of lead 1, for example. Okay, so we draw the vectors. So we drew them here. Lead 2 is, let's just say that it's roughly the double the length of lead 1 and lead 3. Okay, again, how do you draw the vectors? You start from the midline, from the center of the vector. You start from the center of the lead. Okay, because we marked the centers of the leads over here. You start by marking the center of you start from the center of the lead, which you have marked, and you go towards, well, do you go towards the positive or the negative? Well, it says, for example, here, lead 1 is 1 millivolt. So you go positive 1 millivolt. Okay, so plus 1 centimeter. Okay, if it was minus 1 millivolt, it would go minus 1 centimeter. Okay, so basically you're going lead by lead. So the idea of the signs is that, so this is lead 2, this is the positive direction and the negative direction. This is lead 1, positive and negative direction. This is lead 3, positive and negative direction. Okay, so yeah, so basically when you get lead 1 and it's plus 1 millivolt, you draw 1 centimeter towards the positive. Okay, lead 2, 2 centimeters towards the positive, lead 3, 1 centimeter towards the positive. Okay, so that's just rough drawing. Okay, now the next thing you'll do is that you draw lines perpendicular to the heads of the vectors. Okay, so I draw a line. After drawing the vectors as accurately as I could, I draw lines which are perpendicular to them. Okay, I drew one perpendicular to lead 2, one perpendicular to lead 3, and one perpendicular to lead 1. Okay, and you probably noticed by now that they are intersecting in this point, and this point of intersection is what is going to form for us the mean electrical axis. We draw a line from the center of the triangle, which we have designated, and we connect it to the point of intersection of the vectors. And this is this point right here, and this big fat green arrow is the mean electrical axis. Okay, yay. Okay, that's good. However, what is this mean electrical axis? Or rather, like, okay, well, what do we do now? So what we need is that we need to know the angle of this mean electrical axis. Okay, so how do we tell the angle? Well, if you remember from the previous slide, how we designate angles, that's how we'll do it. So basically what we do is that we draw isoelectric line, we draw the midline, we draw the isoelectric line and the midline, and we mark the angles of the isoelectric line and midline. So 0, 90, 180, 270, or minus 90. Okay, we marked the angles, and then we see what is the mean electrical axis. So the mean electrical axis is between 0 degrees and 90 degrees based on this final drawing. Okay, so between 0 and 90 degrees. So for now, I'll tell you, let's just say roughly that I'll give you exact numbers, an exact way of finding the exact number later or soon. But for the time being, let's just say that it's roughly about 60 degrees. Okay, because we start from 0 and we go like that. Okay, we start from 0, we go to clockwise, so it's from 0 to 90. So this is 60 degrees, roughly speaking. Okay, so that is the mean electrical axis. That's how you draw the mean electrical axis. So you will be repeating this for every single question, of course, in a much more simplified manner. I'm just giving you the most complete form of how to do this. However, you'll be blasting through this. You'll be doing this very quickly for each of the questions when you have this later. Okay, you'll notice shortcuts and you'll start skipping over the whole thing very quickly, you know. So that is how you draw Einthoven's triangle. Typically in a seminar, physical seminar, I would repeat this several times and I would wait person by person until every single person gets this. However, you have the advantage of the beauty of technology, in which you can just replay the video if you didn't understand anything. Okay, so that is what's important for you right now, is that right now, if you don't understand any point, stop right here, go back and replay this part, redraw the triangle, whatever. Just get a grip on this this part, because basically this is the most important point of this whole seminar. You're going to be using this for every question, no exaggeration. All right, so that is how you draw Einthoven's triangle. Now we begin with something called the tricks. Okay, so basically, how do you tell? We left on a cliffhanger. So how do you tell what is the exact angle of this? And I said, like, let's just roughly say 60. However, if you type in the computer roughly, let's just say 60, it'll give you roughly. Let's give you an incorrect answer. So you want an exact number. So what is the exact number? So you go that. These are the tricks of how you know the exact number. Okay, and once you get a hang of these tricks, everything is easy peasy. You won't have any problem with ECG whatsoever. Every ECG question you'll be like, yes, I wish the whole exam was ECG questions. Let's go. And so the first trick is that, now bear with me with these tricks. Okay, these tricks are slightly unorthodox, but they work, and so just learn them, and this is the most accurate way of actually getting the Einthoven's triangle angle, especially for your credit test. So just bear with me and listen very carefully, okay? And use your eyes very carefully as well, because you have the presentation. So if mean electrical axis is perpendicular to any lead, its amplitude is 0. If mean electrical axis, now let me repeat, what does amplitude mean? Amplitude means the voltage. So you say, so before we said like lead 2, the voltage of lead 2 is 2 millivolts, okay? And we said lead 1 is 1 millivolt, lead 3 is 1 millivolt, whatever, okay? If we find that the mean electrical axis is perpendicular to any lead, the amplitude of the lead is 0. So for example, if we draw the whole drawing, okay, and they didn't give us for example, if they didn't give us what was lead 1, okay, we drew our drawing and we managed to draw it without needing lead 1, okay, then we use the mean electrical axis. If the mean electrical axis was perpendicular to lead 1, we would be able to tell that lead 1 is 0, and that is how we answer the question, okay? You draw the whole mean electrical axis, and you find out that since mean electrical axis is perpendicular to that lead's amplitude is 0, and vice versa. So basically, instantly from the beginning of the question, and this is a very nice shortcut, if from the beginning of the question he tells you, for example, lead 1 is 0. You are finished. Instantly you know that mean electrical axis will be perpendicular to lead 1. So it's either going to be 90 degrees or minus 90 degrees or 270, whatever. You know, you get what I mean? So basically I'll draw this. I'm going to be using Microsoft Paint because I don't have like any like complicated. So basically to keep things simple, all right? So if we had that mean electrical axis, let's make it like this. So if you had that, I sure hope it's recording. So if we had that the amplitude of lead 1 is 0, we can instantly say that the mean electrical axis is perpendicular to lead 1. So mean electrical axis is either going to look like this, or it's going to look like, in both cases, it is perpendicular, technically, to lead 1. Okay? So, going back. And so, if mean electrical axis is perpendicular to any lead, like we said, its amplitude is 0, okay? And vice versa. So, if we're giving in a question that the lead, some given lead, its amplitude is 0, therefore we instantly know right away what mean electrical axis will be. It'll skip, we don't even have to draw the triangle, or like it'll allow us to skip a whole lot of steps of drawing the triangle just by knowing that, well, the mean electrical axis is perpendicular to that lead. So it's either going to be, for example, like we saw, if lead 1 was 0, it's either going to be 90 or minus 90. Easy as that, you know? And now for some more tricks. And so, as a follow-up point for this, okay, is that the angle of mean electrical axis will be any of the following if the amplitude is 0, okay? So these points are all connected together, all right? So basically, if we have that, for example, a lead's amplitude is 0, therefore, mean electrical axis will be perpendicular to that lead. Therefore, mean electrical axis's angle will be one of these angles, okay? So for example, if it's, if it's in the case of lead 1 being 0, it'll be 90 degrees, okay? Or it'll be 270 or minus 90, okay? Depends on how you look at it. But in all cases, you get what I mean, right? Is that basically if the amplitude of the lead is 0, therefore mean electrical axis will be one of these angles. Or if mean electrical axis is one of these angles, therefore the amplitude of some lead is gonna be 0, you know? So it's vice versa. Everything is vice versa. Okay, if you get it, that basically these tricks are all interconnected. All right. So these angles, what I like to call them is that they're the angles which are 30-ish. Okay, if you get what I mean by 30-ish, it basically what it means is not divisible by 60. Okay, so 30-ish, what I mean is that you start from 30, you add 60, add 60, add 60, add 60, add 60. Okay, or like you jump from 30 minus 30, minus 60 is minus 30. Okay, minus 90. Okay, so basically 30-ish means 30, 90, 150, 210, 270, and minus 30. Okay, and basically the idea of it is that not divisible by 60. Okay, so basically if you're given in the question, it's as simple as this. If you are given in the question that the mean electrical axis is 30-ish, therefore you will know 30-ish not divisible by 60, therefore you will know that mean electrical axis is perpendicular to some lead. Okay, therefore you will know that that lead which mean electrical axis is perpendicular to, that lead's amplitude will be 0. Okay, so all of these are interconnected. All right, I know that it might seem very abstract at the moment. However, as soon as we start tackling examples, and we've got a lot of examples, hopefully you will get the hang of it. All right, and as always, if there's any part that you don't understand, well, I don't have to repeat. You can repeat. You know, you can just repeat the video if you like. Yeah, if I'm going too fast, slow the video down, not a problem. All right, so, or if I'm going too slow, you can just double the speed if you like, if you like to live on the edge. Anyways, so these three factors, so the three factors in this trick, if one is true, the others are true as well. So if mean electrical axis is 30-ish, therefore it'll be perpendicular to some lead, therefore that lead's amplitude will be 0. Or if some lead's amplitude is 0, therefore mean electrical axis, when you're drawing it, it will be perpendicular to that lead. Therefore, the angle of that mean electrical axis will be 30-ish. Or if we find, you get what I mean, you already understand what I mean. If the mean electrical axis is perpendicular to some lead, that lead is 0 and mean electrical axis is 30-ish. Okay, so these interplay, is vice versa. Okay, so that is the first point here. It is this first trick is the trick of 30-ish. Okay, the other trick is the trick of 60-ish. All right, so 30-ish means not divisible by 60. 60-ish means divisible by 60. All right, so if mean electrical axis is parallel to any lead, okay, so basically you would have mean electrical axis which is parallel to some lead. Here it was about being perpendicular. Here it's about being parallel to some lead. All right, so if mean electrical axis is parallel to some lead, that lead will have double the amplitude of either of the two other leads. Okay, what does this mean? So basically, if we've got that, for example, lead 2, okay, if we have that lead 2 is double the amplitude of lead 1, therefore we know that since lead 2 is double that of lead 1, therefore we'll know that the mean electrical axis will be parallel to lead 2. Okay, end of story. You got it? So, and vice versa, if we have that the mean electrical axis is parallel to lead 2, we will, it's like retrograde. It's like if we know that mean electrical axis is parallel to lead 2, we know therefore that lead 2 is double the other leads, double the voltage of other leads. So for example, if they gave us, if you got in a question that mean electrical axis is parallel to lead 2 and lead 3 is 2 millivolts, therefore it's very easy. If it's parallel to lead 2, therefore lead 2 will be double the other leads. And they gave you another lead. They gave you lead 3 is 2 millivolts. Therefore, lead 2 will be double that. So it'll be 4 millivolts. Easy as that, okay? And that solves you the question, all right? And the third ingredient of this salad is that if one is true, the others are true. There are 3 factors in this trick. If one is true, the others are true. So basically, if mean electrical axis is parallel, therefore the lead which it's parallel to will have an amplitude which is double that of the other leads. Also, if mean electrical axis, if the amplitude of some lead is double that of another lead, for example, if we have lead 2 is 2 and lead 1 is 1 millivolt, therefore we know that lead 2 is double lead 1, therefore we know that mean electrical axis will be parallel to lead 2. Okay, last thing is 60-ish. That basically, third ingredient is that basically when mean electrical axis is parallel to some lead, mean electrical axis is parallel to some lead, therefore if mean electrical axis is parallel to some lead, therefore we know that mean electrical axis's angle is 60-ish. Okay, so it's either going to be 0, 60, 120, 180. You see that you start from 0 and you add 60, 60, 60. Okay, 60, 120, 180, 240, minus 60. All right, so it's the same story. All right, so we'll get into details. You'll understand everything a whole lot better once we start getting into the examples. All right, so if that's all right so far, we will continue. If it's not, you can replay. But again, these are the 2 tricks, and all you need to know is to learn these tricks, and you'll now see how to apply them. Okay, so 30-ish perpendicular 0, or 60-ish parallel double. That's what you need. Okay, now let us start with the examples. Oh, before the example, so this is a massive table, right? And basically, okay, I'm just gonna play the animation. Bam. You don't need this table. By knowing the previous tricks, you have avoided learning this table. Okay, you should be happy. Therefore, so we shall now continue. Last thing before we start the examples is just 2 equations. Okay, one equation I'll start with. So there's 2 equations. The one that I'll start with now is this one here, that the voltage of lead 2, and this is a rule always there, that lead 2 voltage is always, or voltage is the same word as amplitude. So lead 2 is always equal to lead 1 plus lead 3. Okay, lead 2 is always equal to lead 1 plus lead 3. And you can move these around, of course, you know, so therefore lead 1 equals, you move this around over there, lead 1 equals lead 2 minus lead 3, or like lead 3 equals lead 2 minus lead 1, and so far. It's algebra, okay? So this equation is very important for solving, all right? Lead 2 is always equal to lead 1 plus lead 3. So if basically, for example, if lead 2 equals 0, lead 1 equals 1, therefore lead 3 must equal negative 1, okay? That's the idea. Or if lead 2 is 2 and lead 1 is 1, therefore lead 3 will have to be positive 1, okay? The next equation is about heart rate, okay? It tells us, let's read the equation and we'll see how to apply it. I'll show you how to apply it. And there's just like one question in which you'll apply it, okay? So basically it tells us that the heart rate is equal to 60 divided by, heart rate is equal to 60 divided by the RR interval, okay? This is how you write it, RR interval, the interval between the two R peaks. What does that mean? So I'll show you what it means. Is that basically, if we go back over here, I don't even need to do that. I'll just go like bam, like that. If we go back here, this right here is the RR interval. It is the distance in millimeters between the two R peaks. Okay, so between this peak and this peak, the distance between them is the RR interval. Okay. Sorry, not in millimeters, but rather in milliseconds, I think, but whatever. So basically, the distance between them is the RR interval. And what you do is that you take 60 divided by the distance between these two peaks, and they give you that in the question typically. And thusly, you have the heart rate, which is the number of beats per minute, for example. You know, number of times the heart beats per minute is the heart rate. All right, so back to where we left off. So we left off here. So you've got now, you have these three things in your head, okay? You have this equation, well, okay. So you have three things in your head: the equations, the tricks, and how to draw an ECG, how to draw an Einthoven's triangle. With those three things, you are ready to tackle the examples, and you're ready for every question for ECG. All you need now is practice, and you'll be ready for anything, all right? So let's start with the first question. First question says, find the direction of a mean electrical axis. Okay, pause there. Find the direction of mean electrical axis. As always, a disclaimer before we start, that biophysics is very easy in that it's as simple as this, okay? You take what they want, you take what they give you, in the question, you check what they want, and you use some sort of equation or mechanism to use what they gave you to give them what they want. It's simple as that, okay? You've got input, you've got required output, and you've got some process, okay? Your goal is to learn that process beforehand, which is for example, the equations, etc., how to draw the triangle, etc. So that's the process, and you take their input and you give them their output by processing it with that process that you've learned. Okay, it is as simple as that. That is the general way of tackling any question in all of physics, including biophysics. Okay, and so starting off here, we first check what is the input that they've given us. The input, what they have given us is that, well, this is the output that they require. They require this output. They require find the direction of mean electrical axis. So this is the output they require. Okay, that's the output. Mean electrical axis of ECG. If the sum of QRS peaks in lead 2, let's read through it all and then I'll translate for you. Okay, if the sum of QRS peaks in lead 2 is twofold when compared to lead 1 and both are positive. Okay, so they have given us the output that they require. They want this output. They want mean electrical axis. Okay, if the sum of QRS peaks in lead 2, what does this mean? It means if the voltage in lead 2, okay? So the sum of QRS, I'll go quickly now and show you this again. Whenever they tell you amplitude, whenever they tell you voltage, it's referring to the same thing, and there's a third way to refer to it, is the sum of QRS. How do you get the voltage? Is that basically you go to the QRS, and you take R, which is the positive value, and subtract from it the value of Q and the value of S. Okay, so if R is at 1 millimeter, okay, and Q is 0.1 and S is 0.2 millimeters, okay, so you take 1 minus 0.1 minus 0.2, and that gives you 0.7. So that is your sum of QRS, which is also known as the voltage, which is also known as the amplitude of QRS complex. Okay, that is what that means. All right, so back to our point. Yes. So it's telling us to, this is the output they want. They want direction of mean electrical axis. If the sum of QRS peaks in lead 2, i.e. if the amplitude of QRS is twofold, i.e. is double, so it's telling us lead 2 is double when compared to lead 1. There we go, we have now got the input. They've given us that the lead 2 is double that of lead 1, all right? And they've told us that both are positive. We'll get to this point at the end. However, now we know that QRS of lead 2 is double that of lead 1. Okay, and they want us to use somehow this information to find the mean electrical axis. Okay, how do we do this? Now you will start to see that a lot of the previous steps of drawing the triangle you will be able to skip. Like, you don't need them fully. You'll find shortcuts and you don't need to use all of those like 8 steps systematically. It's really just a rough thing that will help you solve the questions. You'll see now how we'll be skipping a lot of the steps, like, you know. However, I did find the need to explain every single step of it because so that you know everything. Then after you know everything, you can start making shortcuts. You shouldn't start by the shortcuts, okay? Also, later on, second year, third year, etc., if you know this properly, it's for your own good. Anyways, so first thing is that write the input, write the facts that they've given us. Okay, they have given us that QRS in lead 2 is double that in lead 1. All right, this is what this sentence meant. Okay, therefore mean electrical axis is double lead 2. This is based on the trick that they have given us. All right, this is based on the trick that basically if any lead has double the amplitude of another lead, therefore mean electrical axis will be double that leads. Therefore mean electrical axis will be parallel to that lead. Okay, so mean lead 2 is double lead 1. Therefore mean electrical axis is parallel to lead 2. Okay. So what we do, we now draw the triangle. Okay. Now you just quickly skipped all the steps and just but you'll be drawing it step by step, of course. As was shown in that previous slide, you need to get used to drawing it. Quick triangle, okay? I gotta do it this way because it's a presentation. Anyways, RLF. You draw the triangle. You mark the signs. You draw the centers of the triangles. I didn't really draw it here, but I roughly know where they are. RLF 1, 2, 3. I drew the isoelectric line, and the midline. And now, therefore, see, instantly, we know we skip a lot of the steps already. We know that this is the mean electrical axis. Okay, so basically this is the mean electrical axis. It's parallel to lead 2. Okay, that's instantly what we already know. All right, lead 2 is positive, therefore mean electrical axis will be going in the positive direction of lead 2. So now that we see that mean electrical axis is parallel to lead 2, we know that it's either this angle or this angle. However, how do we know which one it is? For all purposes, it could be this one or it could be this one. Okay, how do we know? That's when we use this part. They said both are positive. They're telling us both lead 2 and lead 1, they're both positive. Okay, so let's try this out. So let's say if mean electrical axis was this one, therefore you're saying that this is on the negative side of lead 1 and this is on the negative side of lead 2, so that won't work. It's not this one. It must be this one. This one is on the positive half of lead 1. This is lead 1. This is the positive half of lead 1. And lead 2, this is the positive half of lead 2. Therefore, it must be this direction. Therefore, we have found the mean electrical axis. Easy as that. Okay? Just by using the trick, just by using a simplified version of the drawing,
And in general, you won't really be drawing vectors at all, or drawing like
parallel lines to the heads of the vectors, none of that. Like usually those steps you won't be doing. This is the typical complexity of the drawing that you will need. This is all you'll need, okay?
So, because lead 2 is positive, therefore mean electrical axis will be going in the direction, in the positive direction of lead 2. Easy peasy, we're done. So instead of going all the way like this and choosing this angle, we instead will choose this angle, just that, okay? And we will get to, and okay, we'll finish the question first, and then I'll add like a question sort of thing. So because lead 2 is positive and lead 1 is positive, therefore it must be it must be so this and this. Therefore it must be this direction of mean electrical axis. Therefore it is this angle, this smaller angle, this green angle, not this big red angle, okay? So it's this small green angle, okay? So if we want to know how much is the angle of mean electrical axis,
I'll give you a second, or you can just pause the video and think about it. What do you think the angle of mean electrical axis is in this context? Well, it's easy. We mark these. It's going to be 0, 90, 180, 270, okay? So the angle of mean electrical axis is going to be between 0 and 90, okay? Also, we know that mean electrical axis is parallel to lead 2, therefore it must be 60-ish, okay? A number divisible by 60. Therefore, it's easy. We need a number which is 60-ish, which is found between 0 and 90. Well, what will that number be? It's gonna be 60. Easy as that, alright? As you see, this is a very easy topic if you master these basic skills of the topic, alright? And hopefully you'll be using these skills like in the future as well, not as much as you would need to when you have a credit test about this particular topic, of course. You'll be dealing with the other parts of ECG, but no problem. Like, this is important for you to know as well, okay? So that is the mean electrical axis, and that is that. Okay, we've solved it. They've asked us to find the direction of mean electrical axis, and we have found it. Mean electrical axis is 60. That easy, alright? If you need to, you can pause here, you can revise this question, you can repeat it. If not, we can go on. So, this question, they're telling us, find the direction of mean electrical axis. So that is what the output they want is. They want the mean electrical axis, okay? If the values of QRS peaks are in lead 1, it's this. Lead 3 is this. Okay, what? Yes. So basically, this is how you tackle it. You already know by now what it means. Like in the previous question, we saw what it means, that the sum of QRS peaks in lead 2. What it meant is that you take Q, you take like QRS and you summate them together. So basically you take R, which is a positive value, and subtract from it Q and S. Alright, so same thing here. So they've given us just a small extra step, but it's still super easy. They've given us that in lead 1, the separate amplitudes are that Q is 0.1, R is 0.8, S is 0.2. So it's gonna be very easy. For lead 1, we just take R, which is 0.8, and subtract from it Q, which is 0.1, subtract from it S, which is 0.2. So 0.8 minus 0.1 minus 0.2, so 0.8 minus 0.1 is 0.7, minus 0.2 becomes 0.5. So lead 1 is positive 0.5, alright? So we just summed up the QRS, so lead 1 is going to be 0.5. And similar idea, lead 3, we take R is 0.2, we subtract from it 0.1, subtract from it 0.6. So 0.2 minus 0.1 gives us 0.1. Minus 0.6, it becomes negative 0.5. So lead 3 is negative 0.5. Alright? So that is that so far. And last thing is that now we have lead 1 is 0.5, lead 3 is negative 0.5, and now, so we summed up the QRSs. Now we can use this simple equation. We know that lead 1 is 0.5. We know that lead 3 is minus 0.5, and we just use both of them together into this equation to find the missing lead, which is lead 2. And lead 2 will be lead 2 equals lead 1 plus lead 3. So lead 2 equals lead 1, which is 0.5, plus lead 3, which is negative 0.5. So 0.5, add to it a negative 0.5, bam, bam, they cancel each other, and it's 0. So lead 2 equals 0, and this should give you a knee-jerk reflex that it's 0, therefore we can now play with this thing, okay? That if, now you sit down and think for it for a second, okay? Try applying those tricks in your mind. Pause the video for a second, try and think about it. Or try and go back to that part of the video where the tricks slide was explained, or go to the trick slide, whatever. Try and think about what to do with this. 3, 2, 1, okay. So, because lead 2 is 0, therefore, mean electrical axis will be perpendicular to lead 2, and the angle of mean electrical axis will thusly be 30-ish, okay? Those are the facts. And therefore, we know that mean electrical axis is perpendicular to lead 2. Now, we can get to our drawing. So, we draw our triangle, and we draw all the details, and now we draw mean electrical axis, which is parallel to lead 2, of course running through the center of the triangle. And there we go. And now we've got the angle is going to be perpendicular, so we select this angle right here, okay? And so this is our angle right here, and our angle is minus 30, okay? Of course, your question will be, why don't we take this angle over here and say that it's like, I don't know, between 90 and 180? So it'd be like, why don't we take this angle? It's like 150 or something like that. Well, because if it was this angle over here, if mean electrical axis was this one, this would give us that lead 1 is negative. Okay, it would give us that lead 1 would have to be negative for us to choose this, and lead 1 is positive. Like we said, lead 1 is positive. All right. Second thing is that if we took this lead 3, this is the positive half of lead 3, okay? Lead 3. This is the positive half of lead 3 if we chose this. They're going towards the same way. The arrow would be going towards, roughly, the direction of the positive of lead 3. Therefore, lead 3 should be positive for us to choose this, and it is not. Lead 3 is minus 0.5. It's negative. So no, we have to choose this one. This one is the one where lead 3 is positive, lead 1 is positive, and lead 3 is negative. Lead 1 is positive, lead 3 is negative. We choose this head. Therefore, we chose this head. Therefore, it is going to go towards this direction, and it's minus 30. One thing I forgot in the previous slide, actually. Now, you might ask, in this previous question, why don't we, for example, choose, I don't know, like this, or something like that? We choose in this direction or something. Of course, it's sort of a stretchy question, but basically, if we were, for some reason, to take the red arrow, if the values were different, and whatever, and why don't we take this angle over here? Well, because you never go this way if the arrow is in this quadrant, okay? This is 1, 2, 3, 4 quadrants, okay? If the arrow is in this quadrant, you never go counterclockwise, because what would you call it then? Minus 120? You can't, it doesn't work. It's up from 0 till minus 90, that's it. And here is from 0 till 270, okay? So 0 to 270, 0 to minus 90. You can't go beyond minus 90 and go like minus 120, and you can't go beyond 270 and go like 330 or something like that, you know? Or whatever, you get what I mean, yeah? So that's that. And so we've completed this question. So because this is the thing, because of their values, we take the direction of mean electrical axis in which lead 1 is positive and lead 3 is negative, and so we chose this direction, all right? So that is the other question completed. So far so good. You can revise if you like. If not, let us continue. So next question is telling us that mean electrical axis of the heart is minus 30. They have given us the mean electrical axis. This is one of the inputs. Okay, so mean electrical axis is minus 30. All right. Entire amplitude of QRS
complex in lead 1 is 0.5. So they've given us amplitude of 0.5 of lead 1, which is 0.5, positive 0.5. Okay, find the same amplitude for lead 3. Okay,
so what they want, the input, they've given us mean electrical axis, which is minus 30. They've given us that lead 1 is 0.5, and they want lead 3. Okay, the amplitude. This is a very easy question. I can give you a second, or you can give yourself many seconds if you want to pause and think about it yourself. So this is actually very easy, because instantly, what is this? This number, which is mean electrical axis, again you go to the tricks, and mean electrical axis is 30-ish. Since it's 30-ish, therefore it is perpendicular to something, okay? And whatever it is perpendicular to, that lead is 0, okay? And we'll use this information. If we know that that lead is 0, therefore we can use that information, that lead being 0, and we can use that equation that we have, 2 equals 1 plus 3, lead 2 equals lead 1 plus 3. We can use that and find the missing lead. Alright, so starting off, draw the triangle and draw the mean electrical axis. They gave us mean electrical axis, let's draw it and find out. We know it's going to be perpendicular, so we just got to find out what is it perpendicular to. Okay, so remember the trick, it is not divisible by 60, minus 30, it's not divisible, therefore it is 30-ish, therefore it's got to be perpendicular to something, therefore whatever it is perpendicular to, it is 0, its amplitude is 0. So right there we've got it. So we have it right here. That's basically, we drew the triangle and we drew it. We roughly drew minus 30. It's gonna be minus 30 is gonna be somewhere in this range. And even if your drawing isn't that accurate, you know from the given information that it's gonna be perpendicular. All right, it's gonna be perpendicular to whatever it's coming in contact with. All right, so it's gonna be minus 30 is gonna be in this range between 0 and minus 90. So it's gonna be in this range. It's gonna be 30-ish. You can roughly try and draw minus 30. But even if you don't, even if your drawing isn't right, even if your triangle is a bit crooked, it might look a bit different. Whatever the case is, you know that it's right here. It is perpendicular to lead 2. All right. So happy days. We're good. It's perpendicular to lead 2. Therefore, lead 2 is 0. Okay. Lead 2 is 0. Therefore, we use this equation and instantly we're set. Lead 2 is 0. So 0 equals lead 1, which is 0.5. We're just plugging in. This is algebra. 0 equals 0.5 plus lead 3. Therefore, we move this number to the other side, and we find that with opposite sign, and we find that lead 3 equals minus 0.5, and we are done. It is really that easy, and that is done. Okay. So if you want to repeat this question, feel free. If not, let's go. Now, slight variation. The mean electrical axis of a heart is 240, okay? So from now, we're going to draw that, all right? Or from now, you should expect that we're going to draw that, all right?
Mean electrical axis is 240. That's the input. So entire amplitude of QRS in lead 1 is minus 1.4. So they gave us lead 1. Find the amplitude of QRS in lead 2, okay? By now, you should have enough practice to be able to do this question entirely on your own, so you can give it a shot. Pull out a piece of paper, draw that triangle real fast, use your logic, use the tricks, use the equation, and find out what they want. They want lead 2. They want amplitude in lead 2 expressed in millivolts. Of course, yeah. Anyways, so step 1, they gave us this angle. Let's draw it, all right? So step 1, draw the triangle and draw the mean electrical axis at that given angle, all right? Remember the trick. 240 is divisible by 60. It is 60-ish, okay? It's 60-ish. Therefore, when we draw, we're going to have to keep in mind that what we draw is going to end up parallel to something, all right? So, whatever it is parallel to, that lead is going to be double some other lead, all right? Or double all the other leads, okay? So, here we draw the triangle, and we drew the triangle, and we drew the mean electrical axis, which is roughly 240, okay? Which is roughly 240 degrees. So when I say roughly 240, so it's gonna be between, so the 0, 90, 180, 270. We want to draw the mean electrical axis between 180 and 270. So we draw an arrow which is roughly in this direction, all right? It looks very good here because it's a presentation, but when you're drawing on a piece of paper, it might not look so pretty, but yeah, fair. Anyways, in all cases, 240 degrees. and so it is going in this direction. Okay, already we know because it's 240, it's got to be going in this direction. You don't even try telling me let's take this angle, because this angle isn't 240. This angle is 240 because it's between 180 and 270. So this is our direction, and we have got that it is 60-ish, therefore it's going to be parallel to something. What does it look like it's going to be parallel to? Well, it's definitely not parallel to lead 1 or lead 3 because it's intersecting with them, okay? So it's impossible for it. But however, it looks pretty parallel to lead 2, therefore it is parallel to lead 2, okay? And so, since it's parallel to lead 2, therefore we can say lead 2 is double the rest of the leads, okay? Lead 2 is double any other lead. And we have here another lead. We have lead 1 is 1.4. The value of it is 1.4, therefore lead 2 will be double that, it will be 2.8, okay? And so, lead 2 is gonna be 2.8, okay? Right? And we're finished with the question, right? Right? Wrong, okay? We're not finished with the question because, yes, we have 2.8, but what is the sign? Like, we know that it's 2.8, but is it positive 2.8 or is it negative 2.8? This is the trick. Technically speaking, if you haven't done anything, you like, if you just write down 2.8, you might get the answer wrong. So what is the sign? Well, this trick about the double any other lead, it's about the value. It's about the value, the magnitude. The magnitude is double, okay? The sign, it depends. It depends on what is given, all right? So, its sign depends on the direction of mean electrical axis. It's very easy. Mean electrical axis is in this direction, and so this direction is the negative direction of lead 2, and so it's as easy as that. That is just going to be lead 2 is minus, lead 2's sign is negative, alright? So it's got to be negative 2.8. It's that easy, alright? So 1.4 by 2, that's the magnitude, that's the value of lead 2. Then, because of the direction of mean electrical axis, lead 2 is minus 2.8. And that is it with that question. That's what you type into the computer and you're done, alright? Just minus 2.8 and you are finished. Alright? Alright? If you like, you can pause. If not, we can continue. Alrighty, so, the next question. Entire QRS in lead AVL is 0. Question mark. Okay. Determine entire QRS complex in lead 2, so they want the amplitude of lead 2, if the same value in lead 1, i.e. if the amplitude in lead 1 is 0.3, okay? So they've given us here that lead 1 is 0.3. They've given us that lead 2, they want it. They want lead 2. They've given us lead 1 is positive 0.3, alright? That's all good. What is this guy? Who is AVL, okay? And they've given us that QRS complex in AVL is 0, okay? What does this mean? Okay, so new lesson for you. This is the next trick to add to your sleep, alright? AVL, what even is AVL, alright? So basically, you remember like RLF, okay? Let's go. So basically, you know how we draw RLF at the bottom? Sorry that the F is down there, but it's basically cut out because I made a mistake in the recording. Anyways, what is AV? AV is the AV leads. It means augmented. I'm not even going to pretend to know what the V is. So, what is AVL? Well, first off, what is AV? It's basically, you remember when we drew that the R, we're always drawing RLF to designate, I know the F is down there, like, so R means right arm, L means left arm, F means foot, so left leg. So there's those three, right? So basically, what is AVL? AVL, or you can say AVR, or AVF, there's three possible ones. What is it? It means A is augmented, V is apparently means vector lead. Augmented vector lead. You don't need to know that, but basically it's just an augmented lead, okay? It's like a powered up lead, okay? What is it? Is a lead which connects some limb, so L, R, or F, it connects it to the chest, okay? So basically, for us, in the terms of drawing, it means a lead which connects between one of these corners of the triangle to the center of the triangle. Alright, so for example, AVL would look like this. Connects from L to the center of the triangle. Alright, so that is AVL. Alright, so
how do we deal with this? All right. So when we know that, like, how do we deal with this in calculation, in drawing, etc.? Well, we've been given that AVL is 0. All right. So AVL is 0. What do we know from our tricks? We know that any lead which is 0, mean electrical axis is perpendicular to that lead, right? So when mean electrical axis is perpendicular to this lead, even in the drawing you'll notice something fishy is happening. Basically, if mean electrical axis is perpendicular to an AV something, it's gonna be parallel to some other lead, alright? So if AVL is 0, therefore, we know in the trick, AVL is 0, or any lead is 0, therefore mean electrical axis will be perpendicular to it. Good, this is perpendicular right here, right? So, when, this is the next trick that you add to your array of tricks, to your salad of tricks, is that basically, whenever a lead, whenever AV something is 0, whenever an augmented lead equals 0, mean electrical axis will be perpendicular to that lead, of course, and it will be parallel to some other lead. So AV is a lead from whatever it is. So AVL is a lead from L, AVR lead from R, AVF is a lead from F to the center of the triangle. So like here, like to there. So from L to center of triangle. So perpendicular to AV. L, for example, here, perpendicular to AVL, means it is parallel to some other lead. So it's parallel to lead 2 right here. Lead, clearly, it is not parallel to lead 1 because it's intersecting, not to lead 3 because it's intersecting here. So it's parallel to lead 2. As we see clearly, it is parallel to lead 2. So what does this tell us? Therefore, it means that lead 2, its amplitude is double the amplitude of any other lead out there. All right. So any other lead by 1 is double lead 1 and also double lead 3. All right. So lead 2 is double the other leads. They've given us another lead. They've given us lead 1. Lead 1 is 0.3, and since lead 1 is 0.3, therefore we see that lead 2 is gonna be 0.6. Easy as that. All right. Question is done. Is the question done? No, it is not, because we know that it's 0.6, but we don't know the sign. Is it thingy? Is it whatchamacallit? Is it 0.6 positive or 0.6 negative? Well, we gotta use the signs, all right? So lead 2 equals double. Its sign, however, depends on the direction of mean electrical axis. Now here's the question. Actually, what is the angle of mean electrical axis? Or basically, we don't need the angle. Rather, we just need to know which direction is it going. Is it actually, do we take this direction or this direction, mean electrical axis? Well, we don't know the angle of mean electrical axis. This isn't its angle. This is just a thing showing that it's perpendicular to AVL. So it could be for all, in all cases, it could very much be just like this up till here, or it could be all the way up till here. So how do we tell? Well, we've been given that lead 1 is 0.3 positive. So if lead 1 is 0.3 positive, therefore it must be this end of the mean electrical axis. Therefore we must choose this one. Why? Because this is, so if we look at lead 1, everything on this side, this half, is going to be positive. Anything on this half is going to be negative in the terms of lead 1. So basically, if this was the direction of mean electrical axis, lead 1 would have been negative. But lead 1 is not negative. Lead 1 is positive 0.3. And since lead 1 is positive 0.3, it must be this one over here. Okay? It must be this direction of the mean electrical axis. Alright? So, therefore, since it is this direction of mean electrical axis, therefore we must choose the lead 2, which is in the same direction. Of course, not this one. This is the opposite direction. We choose this one. Right? We choose this one because this is in the same direction as this one. Alright? So, it is positive 0.6. So it's double 0.3, so it's 0.6. Is it positive or is it negative? It is positive, all right? Because it's in this direction, because lead 1 is in this direction, all right? Is that sign, all right? So this is just a clarification of basically, I drew a big bracket to that goes perpendicular to the center of the lead 1, and so everything on this side is positive. And everything on this side, like not in that encompassed in that bracket, is gonna be negative. All right. So this direction is negative. This direction would make lead 1 negative, but lead 1 is not negative. Lead 1 is positive. Therefore, we must choose this one because lead 1 is positive. We choose this direction of mean electrical axis. Okay, so lead 2 is 0.6. Alright, so it's determined by the sign of lead 1. Alright, is that alright? So, that was a new piece of information for you, but as you see, easy. Next up. Now, we are basically, we are done with all of the questions for the credit test, which are going to be relevant to drawing, okay? So, my advice to you is that after you master this part, okay, and you've gotten the hang of it, you are basically done with the majority of ECG questions. It is all about, they give you one thing and they want the other thing. They give you an amplitude, then they want mean electrical axis, or they give you mean electrical axis and they want the amplitude. Is this or that? And it is very easy. Now, if you master this, you have mastered a massive chunk of ECG. All that remains is 2 very small points, which are a more rare variant of question, but you can still get them. This one right here is about the other equation, about the heart rate equation, which we mentioned before. And this is basically more of an algebra question. No drawing here. Is quite easy as well. So let's tackle it, alright? So, the time interval between 2 successive R peaks of ECG record at rest is 800 milliseconds, alright? So what does this mean? It's telling us the RR interval is 800 milliseconds, alright? So, okay, that's cool. They gave us the RR interval, and that is one point of input. The next thing they give us that this interval decreases by 37% after the load. So a person did a load, so basically he did some exercise, and the interval decreased by 37%. Alright, we'll put that in mind. We'll put that in the list of the things that they have given us as input. And the output they want is express in percentage the corresponding change of the heart rate. Okay, they don't want the new heart rate, and this is very important. If you just enter the value of the new heart rate, it is an incorrect answer. Be very focused on what do they want. Even if all of your steps are correct, if you put, it's a machine, and you just write down, it is a computer. You write down your answer like that, is going to say, I don't know what you did, I don't know what you're talking about, that's not the number I have. That's what the computer will tell you, you know? So it's asking specifically for express in percentage, okay? So basically you would write down, like, for example, 46.5 without the percent sign. Okay, that would be, for example, 46.5, and in your head, percent, okay? That is an example. That is the final answer, for example, okay? It's not necessarily true, but yeah. So, express in percentage the change of the heart rate, okay? So, they want the change of the heart rate, alright? So, they don't want by how many times did the heart rate increase. So like, for example, if the previous heart rate was 100 and the new heart rate is 150, okay? They don't want 150%, okay? No, they want an increase of 50%, because 150% is 50% more than 100%. You get the idea? Yeah, so basically they want in percentage the change of the heart rate, okay? They want it in percentage, so for example 50%, and they want the change of the heart rate. They don't want 150%. Which would mean that the new heart rate is 1.5 times more than the original heart rate. No, they want the change of the heart rate, alright? So, to answer this question, we just write down the equation we have, yeah? So the heart rate, we know that equation, heart rate equals 60 divided by the RR interval. The RR interval is 800 milliseconds, okay? So we can get that the heart rate, by using 800 milliseconds, we can find the heart rate. Technically speaking, if you can manage your way through the algebra, you don't even need to insert this number, alright? You can deal with this whole question without actually inserting this number, alright? So let's see how this goes, alright? So, these are the 2 pieces of things that we wrote down, okay? We wrote down the process, which is the equation of the heart rate, okay? The heart rate equals 60 divided by the RR interval. We wrote down the input they gave us. They told us that, and we don't even need to use this number, 800 milliseconds. Because
for example, what if, like, basically sometimes you need to use the minimum amount of input, okay, without being incorrect. You have to use the minimum amount of input because, well, or you have to learn how to do things by using the minimum amount of input, because, I don't know, in some question, what if he didn't give you the RR interval? And you're just like, where's the RR interval? You don't need it to answer this question, all right? So if they don't give it to you, well, you can say, well, good for you, I don't need it, yeah? Anyways, so you don't need to use this. You can instantly just go heart rate equals this equation, okay? We won't, we'll use this, but we don't need to put anything in. The next thing is that they told us the R peaks is this much, but this interval decreases by 37%. What does this mean? This means that let's say that the old RR interval is 100%, and the new RR interval is 100% decreased by the 37%. So 100% minus 37%, which is 63%. So 100% minus 37% equals 63%. Therefore, the new RR interval is 63% of the old RR interval. New RR interval is 63% of the old RR interval. Okay? So, to put this in numbers, like, you can do it in percentage, but it's a lot better to deal with it in, like, convert the percentage into like decimal instead. So you divide by 100. Okay, so 63% means 0.63 in decimals. 100% is 1. Yeah. So basically, so the new RR interval is 0.63 of the old RR interval. Does that make sense? If it doesn't, replay the video until you understand it. All right. So this is where we get funky. So we have here that, as we saw, that the new RR interval is 0.63 times the old RR interval. That's what we got from this point of logic. Okay, so what do we do? Now is time to get algebraic. All right, so we need to replace these. All right, we are going to replace these with these. All right, how do we do that? And why should we do that? Well, it's because the question itself is asking us to compare heart rates. Okay, not to compare RR intervals. All right, so how do we replace? It's just simple algebra. Basically, we take this to this side and take this to that side. More specifically, we basically multiply both sides by RR interval, then divide both sides by the heart rate. So what is the result? It becomes the RR interval equals 60 divided by the heart rate. Okay, so the RR interval would equal 60 divided by the heart rate. Therefore, we can take wherever it says RR interval, TR1, TR2, and we replace them with 60 over heart rate. So it becomes 60 over heart rate 2, like the new 60 over the new heart rate equals 0.63 multiplied by 60 over the old heart rate. All right, so let's see. There we go. And then, of course, 60 goes away with 60. We replace the delta. So, like I said, we replace the RR interval with 60 over heart rate. Then the 60s knock each other off. All right. So what remains? I'm sorry if that was like multiple steps in one, but basically take it slow. If you need to redo that, redo that. In all cases, what we have, it's just algebra at the end of the day. You know, what we have at the end of the day is this heart rate compared to that heart rate. All right, what is the final form that we want? We want it in the form of new heart rate equals something times the old heart rate. For example, new heart rate equals 150% of the old heart rate. That's what we want. Then when we get that number, we take the 100%, like 150%, and we subtract from it 100%. Why? Because they're asking for the change in heart rate. They don't want the answer to be the new heart rate is 150% of the old heart rate, i.e. the new heart rate is 1.5 times the old heart. No, they want the new heart rate is 0.5 more than the old heart rate. The new heart rate is 50% more than the old heart rate. That is the form that they wanted in. All right. So we replaced the RR intervals with 60 over heart rate. We removed like the 60s knocked each other off, and what remained equal is 1 over the new heart rate equals
0.63 multiplied by 1 over the old heart rate. Okay, now the whole goal is that we need things to be in the form of the new heart rate equals x times the old heart rate. All right, so you can take whatever route you like to reach that end, but in all cases you will reach that end, hopefully. Okay, so I just cross multiplied here and got the heart rate 2 multiplied by 0.63 equals heart rate 1. Okay, then I divided both sides by 0.63 because I want this to be the final form. Okay, just divide both sides by 0.63 and you have that heart rate 2 equals heart rate 1 times 0.63. Okay, because this is the final form that we want. Yeah, heart rate 2 equals x times heart rate 1. Okay, then we just plug this number into our calculator and we get that heart rate 2 equals 1.5873 of heart rate 1. So like heart rate 2 is 1.5 times higher than heart rate 1. And it makes sense because the guy had some exercise, so naturally his new heart rate should be higher than his old heart rate. Makes sense, fair enough. So new heart rate is 1.5 times the old heart rate. You need don't get rid of the digits, of course, you know. So therefore they want, again, in the answer, they want to express the change of heart rate. Okay, so we take, to find out the change of heart rate, we take the new heart rate minus the old heart rate. Okay, so it's like heart rate 2 is 1.5 of heart rate 1 minus 1 of heart rate 1. Okay, and we get that it is equal to 0.58. We multiply this by 100 and we get that it's 58% increase of heart rate. Okay, take your time and repeat this part if you don't understand, but it's just algebra, like, you know. So whatever route takes you to this answer, it is correct. Just make sure that you end up with the correct answer, like, you know. And feel free to revise this part, but I hope that was clear. And yes, so to stress again, what they are asking for is the change of the heart rate. Okay, and so we found here the change. How did we find the change? We took the new heart rate minus the old heart rate. So we took 1.5 times of heart rate 1 minus 1 of heart rate 1, and we got this much. So multiply by 100% to get 58.73% increase. And 58.73 is what you put into the box at the end of the day, like, you know. But of course, you got to round up to 3 significant digits, so 58.7 is what you put into the box in the computer, and that's the correct answer. Yeah. And yeah, that should be everything. As for this question actually, feel free to skip this because this question in particular is actually not going to be present in your credit test, except except if they feel if they feel like being fun. But for the most part, this shouldn't show up in your credit test. This does, however, show up in your pre-oral. There's the test, the written test, which is before the final, the MCQ test, which is before the final. However, I'll just go through it just for benefit if you want to look into this later in your pre-oral. So what they're asking is the whole amplitudes of QRS of bipolar limb leads are not negative. What does this mean? It's that they're telling us that the sign of the amplitudes of the limb leads, i.e. the sign of the amplitude of lead 1, 2, and 3 is not negative. Okay, so the sign of lead 1, lead 2, lead 3 is either 0 or it's positive. It is not negative. Okay, and they're asking us to calculate the possible mean electrical axes. Okay, that's a pretty interesting question. But try and think of the basis of that question, all right? Basically, as we saw before, and I'll actually go back to it. If you remember, we saw over here in where's that bracket at? Hey, bracket, where is it? This question. If you remember here, when we drew this bracket, we saw that basically any mean electrical axis which was on this side, anything here, here, all of these would lead to a positive value for lead 1. Okay. As for anything behind the bracket, all of these angles would lead to a negative value for lead 1. So what does this tell us? For example, here in lead 1, what range of angles would the mean electrical axis be positive? Well, it's anywhere between from minus 90 all the way to plus 90. Okay, so that is the range of positive angles in the case of lead 1 being positive. They want us to do the same thing, only they want to make us keep in mind that lead 2 is also positive and lead 3 is also positive, okay? And they want the range of angles in which lead 1, 2, and 3 are all positive, okay? What are the range of possible angles? It's not difficult. Like, don't worry, it's not difficult. This is how you tackle it. What you do is basically you draw 3 triangles. Each time you draw that big bracket which is like perpendicular to the lead, okay? And you say that everything below this bracket is positive for that lead. For example, like here we did it for lead 1, okay? For lead 1, and we drew the bracket, and basically everything between minus 90, from minus 90 all the way to plus 90, these are all these angles of mean electrical axis will all lead to a positive lead 1. Now in lead 2, the same idea. We drew a bracket which is perpendicular to lead 2 all the way there, and so basically any angle by checking the angles, we find that any angle between minus 30 all the way till 150, all of these would lead to positive readings, okay? The question of course lies, how do we know that this is minus 30? Well, of course, because it is perpendicular to this and it's over here between 0 and minus 90, therefore it must be 30ish, therefore this is negative 30. That's how you do it, okay? And here it's between 90 and 180, and again it's perpendicular to lead 2, the bracket we drew, therefore it's got to be 30ish, and it's between 90 and 180, it's 150, okay? So between minus 30 and 150, okay? So now, what range of values would be both positive in both lead 1 and lead 2? Well, if we say somewhere between like minus 90 is negative. In minus 90, lead 2 would be negative. It's behind the bracket, you know. Minus 60, lead 2 would be negative. Minus 45, lead 2 would be negative, even though lead 1 is positive, okay? Because it is positive. It is inside the bracket of lead 1, but it's still negative for lead 2. Up until minus 30. Once you go minus 30 and beyond, it is positive. It is positive in lead 2. It is on this side of the bracket. And it's also positive for lead 1. All the way until 90. Beyond 90, like 100 degrees, 120 degrees, all the way up until 150, lead 2 is positive. But lead 1 is not. Like beyond 90 degrees, lead 1 is going to be negative, actually, you know? You got the idea? I sure hope so. If not, then feel free to repeat, you know? So that's lead 1, lead 2, and do the same logic exactly for lead 3. Lead 3, same idea. You draw that bracket which is perpendicular to lead 3, and you measure the angles with the same ideas, 30ish, and you see what is the range of angles, blah blah blah. You find that between the angles of 30 all the way up until 210, from 30 till 210, all this is a range in which it is positive, okay? So basically, an angle which is, let's say, minus 90, only lead 1 is positive. Minus 10, lead 2 is also positive, lead 1 is also positive. But in minus 10, lead 3 is not positive. Lead 3 only starts being positive from 30 degrees onwards, okay? All the way until 210. However, lead 1 is only positive up until 90 degrees. So therefore, we can draw a table, all right? Draw 3 steps, blah 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 blah. We can draw a table, okay? The minimum angle and the maximum angle in which each one is positive. Minimum, maximum, minimum, maximum. And so we take the biggest minimum and the smallest maximum, okay? The biggest minimum is 30 degrees, okay? So basically, anything before 30 degrees, this is the minimum that we can take. Like we take the biggest minimum, because anything smaller than that minimum would mean, for example, let's take 0 degrees. It would be negative for lead 3. So we don't take that. No, we take the biggest minimum here. So plus 30 is where lead 3 starts to be positive, okay? Therefore, all of them would be positive. It would fit for all of them. And we take the smallest maximum. Why? Because if we took anything beyond this maximum, it would end up being that lead 1 is no longer positive.
plus 150, for example, 150 degrees, or let's say 120. 120 is positive here, but it's negative in lead 1, okay? So all it is, the idea behind this question is that you just draw your triangles, make this table, and you come with the conclusion. Take the range of angles in which all leads are positive, you end up from plus 30 to plus 90, okay? So the trick here is that for the pre-oral, okay, you're gonna have a bunch of questions which are quite new questions. There are some practice questions for these pre-oral questions. However, the tricky thing is that like, how do I say this? They're often new ideas, okay? Like a new idea like this question, it is a new idea. You got to get your brain working, you know, and you can never, there's always going to be new questions on the pre-oral, you know, so there's always going to be new ideas. You therefore have to know your bases, and you build on your bases. Like, you know, even if you get surprised by a new question, you got to use your knowledge that you already have and work your way through such a question, you know. So that's how you tackle it, and if that's all right, we can proceed. The last part of ECG is membrane polarity. This is a very, very I remember we had this in like maybe around the first lecture, and basically we like needless to say, there's a big equation. Even there's a modification of this one which is even bigger. Needless to say, everyone was intimidated and people started to go to lectures a lot less because they're like, boy, because it was just a super long equation and it looks intimidating, but really this is so easy to deal with. Okay, it is called the Nernst equation. It is for calculating Nernst potential. Nernst potential is like a measure of the membrane potential. Okay, let's just simplify it and say that that's what it is. Okay, and how do you calculate it? It's very simple. You just all of these, you just plug in the numbers. That's all you need to do. You just plug in the numbers. Yeah. So what do I mean? So basically, U is typically what they want or what they'll give you, and they'll ask for this. Okay. So they'll, for example, want U. They'll ask you for the Nernst potential, and they'll give you that. R, and all of these are constants, which you will learn. Okay. So R is gas constant, which is 8.314. So you just plug in 8.314 there. T is temperature in kelvins. Okay. The absolute temperature of the environment. Therefore, whatever number you get for temperature, for example, body temperature is 37.5, or if they give you 37, that's okay. You take the 36.5 actually, sorry. So you take this 37 plus 273.15, okay? So that's the whole trick, is that to convert from Celsius to Kelvin, you add 273.15. You'll find this in your constants sheet. All right. So Z is valence of an ion. So for example, in the question, if they give you sodium, sodium's valence is +1 based on its chemical charge, you know, of the ion. You know, chlorine is -1. You know, fluorine is -1. All these things, like, you know, calcium is +2. These things. That's what Z is. Okay. Z is that valence, and that's what it is. Faraday's constant, F, is this number. Okay. And that's pretty much it. Ln is the natural logarithm, and you can find it on your calculator. Okay, it's a button. You press it. It's ln of this. It's like RT over ZF multiplied by ln of this. Ln of CX over external over C internal. Okay, ln of C external over C internal. C external is the concentration of the ion in the extracellular space, and C internal is the concentration in the intracellular space. Okay, what they would give you in the question typically is blah 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 blah, a lot of input, and the concentration in the extracellular space is, for example, 5 times more than the concentration in the intracellular space. What does this tell you? Concentration in the extracellular is 5 times more than the intracellular, so you just take, like, therefore it'll be 5 times of the intracellular divided by the intracellular. Blom blom, they knock each other off, and it becomes 5. So ln 5. That's all you do. Ln 5. So we'll get to an example of this in a moment. So onwards, we will just have a single example of this. It's very easy. It's just because all it is really just plugging in the numbers. So they're asking for the Nernst potential
For chloride ions, so that's Z valence of -1. In normal body temperature, you have that number in your constants list, but I think so. It'll be 37. 37 is typically what they use. So 37, and you got to convert it into kelvins. So it's 37 plus 273.15. If their concentration in the extracellular space is 7 times higher than the intracellular space, so it'd be 7 divided like cellular C external is 7 times more than C internal, so it'd be 7 times C internal over C internal. They knock each other off and it just becomes 7. Okay, ln 7. Take into consideration of the sign convention just means use the correct charge for the ion. So chloride ions, you do it -1, not +1. Okay, so it's very easy. All we do is we wrote down the equation, we plugged in the numbers. This gas constant times T temperature is 37 plus 273.15 to convert into kelvins, divided by Z, which is -1, F, which is Faraday's constant, multiplied by the ln of C external over internal, which is 7, because 7 times higher. So basically, C external is replaced and we put it in its place 7 times of C internal. So 7 times C internal divided by C internal. C internal knocks off C internal and just becomes ln of 7. So ln 7. Yeah, and we just plug that number into our calculator and we get the answer. This is the answer. We're done? Easy, isn't it? Stop right there. Always read the question to its entirety and always check what they want from you. What is the unit that they want? They said express the result in millivolts. This is very important. So this is the answer in volts. If you put this into the computer, it will give you a wrong answer. So you have to put it in millivolts. Okay, it's negative 0.052 volts. So to convert to millivolts, you have to multiply it by 1,000. So this is in volts. We have to multiply it by 1,000 to convert it to millivolts, and so we do, and it gives us minus 52 millivolts. And this minus, and you put the minus into the computer, of course, minus 52 is what you write down into the computer. Okay, and that is it for this presentation. I wish you guys all the best, and I must clarify these important points. First off, watch out for the charge of the ion. This is particular for this question. Okay, so like, don't do +1 when it's chloride. Chloride is -1. Okay, fluorine is -1. Sodium +1. Calcium +2. Okay, easy. Check your constants. Okay, sometimes you will be overly confident and you're like, oh yeah, I know the gas constant. Okay, and you write down, gas constant is 8.312 or something like that, and that's wrong. You know, you got the number wrong and it could mess up your answer. Okay, so you gotta know, they've given you free access to the constant list to use during the test, so just use it. Like, always confirm that you got the right constant. You're using the right you're using the constant correctly. Okay, you'll get used to it, but like you'll know the constant after many trials. But just sometimes it's better to play it safe. Remember your equations. This is probably one of your main jobs, because like I said, the general rule of physics as a whole, and which includes biophysics, is that basically you've got input, you've got process, you've got output. Okay, they ask you for output, they give you output, they give you input, and you are expected to use a process. You're expected to know a process, which is like an equation with which you process the input to produce the output. It's as easy as that. You just gotta know your processes. You gotta know your equations. That's what you got to remember, so make sure to learn your equations. Lastly, know how to round to 3 significant figures. Please, if you don't know how to do this, go and Google it, okay? Or watch a YouTube video on it, but it's very important to know how to round up to 3 significant figures, okay? So, yes, go check Google Images for it, YouTube it, know it well. It's very, very easy, but just know it, okay? Always check what unit they want. And as we saw in this last question, we got bamboozled. It's like we thought it was volts, but actually they wanted in millivolts. We didn't check the question properly. We end up making a mistake. So this is very important. And that is all. And I wish you guys all the best. And goodbye.